All right, so you sent us this article, and it's about these seriously huge GE galaxies
Yeah.
that the James Webb Space Telescope found,
Yeah.
and they're from the early universe.
Yeah.
And honestly, it's kind of messing with everything we thought we knew
Right.
about how galaxies form, you know? We're
Yeah.
talking about galaxies the size of the Milky Way.
Uh-huh.
But get this, they existed less than 1 billion years
Oh, wow.
after the Big Bang.
Crazy.
So I'm already like geeking out about this.
Yeah.
So let's bring in our expert to help us unpack this a little bit.
Sound good.
So I get that these galaxies are massive
Yeah.
and super old,
Mm-hmm.
but what makes them red monsters exactly?
Well,
Do they actually look like giant red blobs?
No, not exactly.
Too bad.
What's really mind-boggling is that they're churning out stars at an incredible rate.
Really?
It's way faster than our models predicted, especially for galaxies so early in the universe's timeline. So they appear red because they're incredibly dusty. You can think of it like looking at a sunset.
Okay.
The dust scatters away the shorter blue wavelengths of light, leaving behind the longer redder hues.
I see.
And this redshift effect is actually a key tool for astronomers studying the earliest galaxies.
So it's like looking back in time.
Exactly. It's like peeking into a time capsule
Wow.
from the universe's infancy.
That's a cool way to put it.
Yeah.
But how did they even find these things?
Right.
I mean, space is huge.
Yeah.
And these galaxies existed billions of years ago.
Billions of years ago. That's right.
Like how?
So they were discovered through a program called FRESCO.
Fresco.
Yeah. And it uses the James Webb Telescope's NICAM
Okay.
/ GRISM spectrograph.
I see.
Now, the spectrograph is a game changer.
Okay.
It splits light from these distant galaxies into different wavelengths,
Okay.
kind of like a prism creating a rainbow.
Uh-huh.
And this allows astronomers to measure the galaxy's distance and how many stars it's packing.
So it's not just taking pretty pictures. It's getting some serious data.
Absolutely.
And what's interesting is that most of the galaxies in the Fresco survey
Right.
actually fit our current models
Yeah.
of galaxy formation, right?
Exactly. Most galaxies seem to follow the expected pattern.
Okay.
Slow and steady accumulation of gas within dark matter halos,
Right.
with only about 20% of that gas turning into stars.
Okay, so these red monsters are like,
Yeah,
nah, we're going to do things differently.
that's putting it mildly.
Okay.
They seem to be forming stars at twice the efficiency.
Really?
It's like they had a turbo boost,
Wow.
and that's throwing a big wrench into what we call the too many too massive problem.
Okay, you got to explain that one.
Sure.
What is the too many, too massive problem?
It's the question of how these supersized galaxies managed to form so quickly
Uh-huh.
in the early universe.
Right.
They shouldn't have had enough time to pull in all that gas and convert it to stars at that rate, at least according to our current models.
This is really making me rethink everything I thought I knew about the early universe.
Yeah.
Could you walk me through some of the alternative theories researchers are exploring?
Yeah, so one intriguing possibility is that these early red monsters might have formed in regions of the universe that were denser than average, kind of like cosmic hotspots.
Okay.
This would have given them a head start,
Uh-huh.
like having a buffet of gas and dust right at their doorstep
Right.
to fuel star formation.
So location, 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 even in the early universe.
Yeah, exactly.
Are there any other ideas about how they pulled off this rapid growth?
Another possibility is that we're seeing the aftermath of galactic mergers.
Oh, okay.
You can imagine smaller galaxies colliding and combining, pooling their resources, and triggering a massive burst of star formation.
It's like a cosmic recipe.
Yeah, it's like a cosmic recipe where combining ingredients leads to an explosion of flavor, or in this case, stars.
Okay, now that's just cool.
Yeah.
Do we have any visual data of these mergers? Or is this mostly a theoretical model at this point?
That's where the upcoming research gets really exciting.
Okay.
To truly understand what's happening,
Uh-huh.
we need to dig deeper into the environments surrounding these red monsters.
Okay.
And that's where LMA comes in.
LMA, that massive array of radio telescopes
Yes.
in Chile.
That's right.
What can they tell us about these ancient galaxies?
Well, LMA is fantastic at observing cold gas and dust,
Okay.
which is essentially the fuel for star formation.
Right.
By combining data from both the James Webb Telescope and LMA,
Uh-huh.
astronomers can get a much more comprehensive picture of what's happening in these early galaxies.
It's like having a cosmic detective team.
Exactly.
So we've got these incredibly massive and ancient galaxies challenging our models of the early universe.
Right.
And now we're gearing up to investigate them further with some of the most powerful telescopes on Earth.
Yeah.
I can't wait to see what we discover.
Me too.
But before we get ahead of ourselves...
Okay. It really is a fascinating puzzle, isn't it?
Yeah, it is.
And the implications of these red monsters go far beyond just tweaking our galaxy formation models.
Okay, so let's zoom out a bit.
Okay.
If we connect these red monsters to the bigger picture,
Right.
what are we actually looking at here?
Well,
What does it mean for our understanding?
it challenges
Just how the universe evolved.
it challenges the traditional view of the early universe as this calm, gradual process of galaxy formation.
Okay.
These red monsters suggest that there were periods of intense activity,
So, like,
almost like the universe was going through a growth spurt.
that's an awesome way to put it.
Yeah.
So are you saying that we have to, like, toss out everything we thought we knew
Not necessarily,
about
but
the early universe?
the standard cosmological model, which explains the universe's evolution from the Big Bang onward,
Right.
is still a solid framework.
Okay.
But we might need to add a few new chapters to account for these early bloomers.
Okay, so more like an edit
Yeah.
than a complete rewrite.
Exactly.
But it still raises some pretty big questions, right?
Absolutely.
I mean, if these galaxies grew so fast,
Right.
what else might we have missed?
That's the exciting part.
Yeah.
These red monsters are like beacons,
Yeah.
pointing us toward areas of the early universe that were perhaps more dynamic and complex than we initially imagined.
I'm trying to wrap my head around the sheer scale of this.
Yeah.
Like, what would it have been like to actually witness these red monsters forming
Oh, wow.
in the early universe?
Just imagine a cosmic landscape filled with swirling gas and dust, pockets of intense energy,
Wow.
and these massive galaxies blazing with the light of millions of newborn stars.
That's incredible.
It would have been a truly awe-inspiring spectacle.
You're painting quite a picture.
I try.
But let's bring it back to the research.
Sure.
What are the next steps in studying these red monsters?
Well, we need to scrutinize their structure, their
Mhm.
chemical makeup,
Mm-hmm.
and the rate at which they're churning out stars.
Right.
The James Webb Telescope will be crucial for this,
Okay.
providing us with unprecedented detail.
And I bet the search is on for more red monsters.
Absolutely.
If we found 3, there must be others out there, right?
The more we find, the better we'll understand whether they're just cosmic anomalies
Right.
or represent a more common phase of early galaxy evolution.
It's like each new discovery opens up a whole new set of questions.
Exactly. And that constant drive to learn,
Yeah.
to uncover the mysteries of the universe is what makes science so compelling.
Right.
These red monsters are a perfect example of that.
Uh-huh.
They've thrown a curveball at our understanding of the early universe
Yeah.
and sparked a wave of new research.
It feels like we're standing on the precipice of a whole new era in astronomy,
I think so.
all thanks to the power of the James Webb Telescope.
It's a golden age of discovery.
Wow.
And these early galaxies are just the tip of the iceberg.
That's amazing.
Who knows what other wonders and mind-boggling phenomena are waiting to be uncovered.
Okay, so we've been diving deep, you
Yeah.
know, into these red monsters,
Wow.
these just galactic giants from the early universe.
Yeah.
And they're really shaken up.
They really are.
Our understanding of how galaxies form.
Yeah.
It's been a wild ride.
It has been quite a journey,
Yeah.
hasn't it?
Yeah.
And we've only just scratched the surface
Right.
of what these discoveries might mean.
But before we get lost
Sure.
in all like the cosmic implications,
Yeah.
I want to bring it back down to Earth for a minute
Okay.
for our listeners who might not be, you know, astrophysicists.
Right.
What's the what's factor here?
That's a great question.
Why should they care about these?
It is easy to think of astronomy as this esoteric field,
Right.
detached from our everyday lives.
Yeah.
But in reality, understanding the early universe is about understanding our own origins. These
yeah.
red monsters,
Yeah.
these massive galaxies forming so early in the universe's history, give us clues about the processes that ultimately led to the formation of our own galaxy, the Milky Way,
Right.
and even our solar system.
So it's like tracing our family tree
Exactly.
back to the very beginning.
Yeah.
But on a cosmic scale.
Exactly. By studying these ancient galaxies, we gain insights into the fundamental laws of physics
Wow.
that govern the universe and the conditions that allowed for the emergence of stars, planets, and ultimately life itself.
Wow. I'm starting to see the bigger picture now.
Good.
So it's not just about these red monsters themselves.
Right.
It's about what they reveal about the grand narrative of the universe.
Precisely. And this discovery underscores that the universe is full of surprises.
Right.
Even with our sophisticated models and advanced telescopes, there's still so much we don't know.
This whole deep dive has really highlighted the limitations of our current understanding.
Yeah.
So what are some of the big unknowns that future telescopes might help us solve?
Well, for one, we still don't fully understand the role of dark matter and dark energy in galaxy formation.
Yeah. Okay.
These mysterious entities make up the vast majority of the universe's mass and energy.
Wow.
Yet we can't directly observe them.
So they're like the invisible puppet masters of the cosmos.
In a way, yes, future telescopes with even greater sensitivity and resolution might help us unlock the secrets of dark matter and dark energy and how they influence the formation of the first galaxies.
Wow. It feels like we're at the dawn of a new era of cosmic exploration.
I couldn't agree more.
And the James Webb Telescope is leading the charge.
And as we continue to peer deeper into the universe's past,
Yeah.
I have no doubt we'll encounter even more mind-boggling discoveries that will challenge our assumptions and reshape our understanding of the cosmos.
It makes you wonder what other monsters might be lurking out there.
Exactly.
Just waiting to be discovered.
And that's the beauty of science. It's a never-ending quest for knowledge driven by curiosity and wonder.
Wow.
And who knows what amazing revelations await us in the vastness of space.
Well said. So for all you listeners out there, keep that curiosity burning, keep exploring, keep questioning, and keep looking up at the stars. We'll catch you on our next deep dive into the mysteries of the universe.